The greatest tectonic plate on our planet may be splintering right now beneath the endless blue of the Pacific Ocean. Scientists are detecting tremors in places no one expected, volcanoes bursting through seemingly solid rock, and fragments of crust tearing away from the giant itself. If this titanic slab truly begins to fracture, the results could redraw the map of Earth and unleash natural forces beyond anything humanity has ever witnessed. But just how close are we to that breaking point? Let's dive in. The Pacific Plate is a behemoth, the single largest piece of Earth's outer shell. It stretches over more than a third of the planet's surface, wider than all of North America and Eurasia combined. And it's anything but still. This vast plate drifts northwest at nearly 11 centimeters per year, among the fastest of Earth's moving slabs. Over tens of millions of years, that constant motion has sculpted the ocean basin, raised fiery island chains such as Hawaii, and powered the ring of volcanoes and earthquakes that outline the Pacific's rim, the infamous Ring of Fire. For decades, geologists regarded the Pacific Plate as unbreakable, a coherent, stable block of rock capable of transmitting stress across thousands of kilometers. It was the symbol of geologic endurance. But that sense of permanence was an illusion. Beneath the waves, faint fractures and mysterious tremors are revealing a new reality. The Pacific Plate might not be the solid monolith we once believed. Subtle warnings are emerging in the least expected regions of the seafloor. For much of the 20th century, scientists assumed that tectonic plates only fractured along their edges. At subduction zones where one plate sinks beneath another, at transform faults where plates grind side by side, or at spreading ridges where new crust forms. Yet the Pacific Plate began to defy that rulebook. Small, measurable distortions appeared in what should have been calm, rigid crust. And then something stranger followed, earthquakes occurring far from any boundary. These weren't city-leveling megaquakes, but modest tremors, quiet by comparison, yet their locations were shocking. They struck deep within the plate's interior, in places where earthquakes simply shouldn't exist. To geologists, this was the first clue that the Pacific Plate might not be one unbroken slab after all. Instead, it may be a vast mosaic crisscrossed by hidden fault lines, some ancient, others newly born. And the strongest evidence for those unseen fractures? Earthquakes igniting in locations that textbooks once marked as stable. Ordinarily, quakes make sense. They occur where plates collide, grind, or split apart. But in the heart of the Pacific, seismographs began recording rumblings with no clear cause. Near Hawaii, clusters of small quakes rippled through the seafloor, far from any subduction zone or transform fault. They didn't fit the traditional map of tectonic activity. In other remote stretches of the Central Pacific, isolated jolts appeared in regions long thought geologically dormant. Each event was minor, yet together they painted a disturbing picture. Stresses traveling deep inside the plate itself. To researchers, these intraplate quakes were red flags. A supposedly solid expanse of crust was bending, flexing, even cracking under hidden strain. When scientists traced the tremors back to their origins, the story grew even more dramatic. Volcanoes were literally punching holes through the Pacific Plate. The oddest earthquakes weren't random at all. Many clustered around hotspots, plumes of molten rock rising from deep within the mantle, melting their way upward and piercing the plate like a torch through metal. Hawaii offers the clearest example. Each island in the chain marks a new position of the plate as it drifts over a stationary hotspot. But every eruption required the lithosphere to split, allowing magma to burst through rock once considered unbreakable. Roughly 47 million years ago, the Hawaiian Emperor Seamount chain suddenly bent about 60 degrees. That sharp kink records a dramatic shift in the Pacific Plate's direction, and a moment when immense stresses literally changed how the crust fractured. Nor is Hawaii unique. In the South Pacific, hotspots beneath Samoa and Tahiti exploit existing weaknesses, driving massive volcanoes upward and hinting that this so-called titan of tectonics is far more fragile than we ever imagined. Yet the most revealing clue that the Pacific Plate is no longer whole isn't a single volcano or an isolated quake. It's the discovery that entire pieces of this once monolithic plate are tearing free. Geologists now call them microplates, smaller fragments splitting off from the parent slab. If the earthquakes and volcanic bursts weren't enough, these tiny tectonic shards confirm that the Pacific plate is fracturing. Microplates often emerge at points where spreading ridges, transform faults, and fracture zones intersect in tangled geometries known as triple junctions. As the Pacific plate pushes forward, strain accumulates at those junctions until the crust finally rips apart. Over vast spans of geological time, microplates rarely stay miniature. They can drift, collide, merge, or expand, carving what was once a single immense plate into a patchwork of new tectonic pieces. And as strange as this might sound, Earth has seen it before. The Pacific plate may seem immense and unshakable today, but it isn't the first giant to face the relentless crush of Earth's internal forces. Tens of millions of years ago, another colossal plate, the Farallon, sprawled across most of the eastern Pacific. It was every bit as mighty as the Pacific plate is now. But over time, the Farallon was dragged beneath the growing continents of the Americas, subducted piece by piece until only fragments survived. Three of those remnants endure as separate plates: the Cocos, the Nazca, and the Juan de Fuca. Their names might sound obscure, yet their impact on modern geology is monumental. Off the Pacific Northwest coast, the Juan de Fuca plate is still slowly sliding beneath North America. This region is the Cascadia subduction zone, one of the most dangerous fault systems on the planet. Geologists warn that Cascadia is capable of producing an earthquake exceeding magnitude 9, shaking the entire region from Northern California to British Columbia, followed by a tsunami that could devastate coastal cities. The Farallon's collapse is a stark reminder that no tectonic plate, no matter how vast, lasts forever. Its destruction shows exactly how a seemingly indestructible plate can disintegrate, and how the process can spawn catastrophic seismic zones that persist for millions of years. Now, as the Pacific plate begins to display similar warning signs, some scientists fear that history may be repeating itself. We might be witnessing the early stages of another giant's slow and inevitable collapse. But this isn't merely an academic question or a geological curiosity. The consequences reach directly into the lives of hundreds of millions of people who inhabit the shores of the Pacific Ocean. The so-called Ring of Fire already outlines the most seismically active boundary on Earth, a continuous chain of trenches, faults, and volcanic arcs that stretches from Japan and the Philippines down through Indonesia and New Zealand, curving eastward to Chile, Mexico, and the western coasts of the Americas. More than 800 million people live within this restless rim where earthquakes and eruptions are part of everyday life. If the Pacific plate is now cracking internally, that danger only grows greater. Internal stresses could redistribute strain along the plate's outer boundaries, triggering quakes even larger than scientists currently anticipate. Volcanic arcs might reignite with renewed energy, while fractures forming in the middle of the ocean could one day create hazards in places once thought immune to seismic activity. Researchers are particularly uneasy about regions already under extreme tension. Places like the Cascadia subduction zone, Japan's Nankai Trough, and the Chilean Trench. Each of these fault systems is capable of unleashing magnitude 9 megaquakes, followed by tsunamis that could race across entire oceans. That leads to a daunting question. What happens if the Pacific plate truly begins to tear apart? When geologists study the cracks spreading across the Pacific plate, they're not just peering into the past, they're looking ahead, trying to foresee the next rupture, the next eruption, the next chain of events that could reshape the world's coastlines and affect millions of lives. Because the more we comprehend these deep processes, the better prepared we'll be for the shocks that inevitably follow. The Pacific plate may be vast, but even the largest features on Earth are fleeting on geological timescales. The fractures forming today could be the first lines of a new chapter in the planet's story, one that will unfold long after our own era has passed. So while the giant stirs beneath the waves, humanity stands at a crossroads. We can watch in awe, or we can listen and learn, building stronger cities, enhancing early warning systems, and respecting the immense power of the forces beneath us. The cracking of the Pacific plate is both a warning and a call to understanding, a sign that even the mightiest structures of our world are transient, and that the future of Earth's surface is still being written in stone. For humanity, the lesson is clear. Stability is temporary. The same forces that created the islands, trenches, and mountains we admire can also erase them. The ground beneath. If you want to stay ahead of Earth's hidden forces, from megaquakes to supervolcanoes, stay curious, stay prepared, and keep exploring the planet's restless heart. Because while the Pacific plate may be shifting, our quest to understand it has only just begun.